Hi guys, so in this video I'm going to go ahead and go through the examples for the practice exam. Remember, it's your job after each example to stop and create a multiple choice question that's similar, and you have to do that for at least 4 questions. Please do not do it for the 4 easiest questions. Do it for 4 questions that you struggled with, because then those questions become really good practice as you prepare for Wednesday's test. We'll start right now. Go ahead and pause the video. You will answer question 1 in Edpuzzle, and then when you submit your answer, I will explain it. Remember that skipping is enabled, so if you get the first question right, I'm going to go ahead and explain, but you can skip my explanation by navigating to the next little green box at the bottom of your screen, which indicates when the next question starts. Question 1. Right, so here we go, answers to question 1. As most of you probably figured out right away, this is just a straight up quotient rule. The instructions notation, this is saying to take the derivative of y, and y is one function divided by another. I set up my quotient rule here, and then I just distributed out the top and simplified the terms right here, which turns into e. If you need to look at the work for any more time, pause the video. Otherwise, let's do question 2. Excellent. So question 2 is one that I've talked about with a number of you. And the first thing I would do is just identify what you're talking about here. So they're telling us about the derivative of f times g. In other words, I knew to use the product rule. It is also telling me that I'm talking about a particular number, not just an expression altogether. So the derivative of a product at a particular point, I followed the product rule, but instead of just saying u dv v du, I said u of -1. In this case, it really was f of -1, g prime of -1. And then what I recognize in this expression is that I know what this is, because they tell me that 4 is the derivative at -1. I know what f of -1 is because I just plugged in -1 to the f function. I know what g prime of -1 is because they tell me it. And what I'm looking for is g of -1. Now, this x is really not the same x as up here. This x is just telling me that that's what I'm looking for because the question's asking for that number. And I know what f prime of -1 is because I can take the derivative of f, and then I can plug in -1 there, and that's how I got the -2. Now, this is just a linear equation. I've got a variable and a bunch of numbers, so all I need to do is just solve it, which is a very simple process, and it gives me a +4. If you need to look at any of this work again, please pause the video. Otherwise, let's move on to question 3. Great, and I'm cut off a little bit here. Question 3 starts in a very similar fashion. So I recognized, first of all, that what I'm looking at here is a chain rule. Some of you may have used a quotient rule. You should still have the right answer. But in my opinion, chain rule is easiest when you have just a number on top. Instead of thinking this as a fraction, let's think of it as f of x to the -1. So I know that g of x equals f of x to the -1. That's just what's given to me. If I take the derivative of both sides of this equation, it turns out that the derivative of g prime of x, is the same thing as -1 times f of x to the -2 times f prime of x. That's literally just the chain rule right there. And then, of course, the question is really asking me what's going to happen at g prime of 0, and so that's where I get the 1/2 from. I plug in all of the zeros, f of 0, which I can get from right here, f prime of 0, and then the rest is just simplifying. If you need to look at this last one anymore, go ahead and pause the work. I'm trying to show it all to you here. Otherwise, we'll move on to the next question. Right, so question 4. So this question was actually just testing whether you know the definition of a derivative. F prime of x sub 0 means the derivative of the function f at this particular point. Well, you guys know 4 different ways to talk about the derivative. The derivative is the limit of the difference quotient. The derivative is the instantaneous rate of change, which is the same thing as the slope of the function, which is the same thing as the slope of a tangent line. And if you're able to come up with all of those understandings, you're going to see, wait, that's a tangent line right there. They tell us that the slope is -1/3. And not only is this any old tangent line, it's a line that's tangent at this exact point that we're interested in. So that's the derivative, the slope of the line tangent at that point, just like that, nothing else. How about question 5? Just kidding, there's no 5. Question 6. All right, question 6 is really just a pretty straightforward quotient rule, but there is a chain rule inside of the quotient rule because of that 3x. Here's how I set it up. V is sine of x, du is the derivative of cosine of 3x, u is cosine of 3x, and dv is the derivative of sine, all over v squared. From there, you've got some trig work to do because we're plugging in pi/6. The way I like to do trig is I will draw my unit circle and I'll draw pi, which is the first half. And then I divide it into 6 segments, which makes it easy for me to see that pi/6 is this one right here. And then I remember that the longer side is the x, so the √3/2 is the x coordinate, and of course 1/2 becomes then the y coordinate. I also need to think about what pi/2 would be, because if I take pi/6 and I multiply it times 3, as I have to in this expression and in this expression, 3 times pi/6 is actually pi/2. Work it out, fraction rules. So pi/2 here, this point is why sine of 3x equals -1. That's a total lie. This point right here is why, oh yeah, it's negative sine of 3x, so it's -1 right there. And then from there, you just keep change flip with the fractions. It's a little bit annoying. Maybe this is where you tripped up at the end, but you do come out with a -6. If you need to look at this any longer, go ahead and press pause here. Otherwise, we'll move on. Right, so question 7 and 8 both use this little table thing here. Go ahead and answer question 7. Question 7 is just a pretty simple chain rule. Here's how I worked it out. Notice that your work is really easy if you make sure that you use equal signs and you label everything. A lot of people probably could have just written down this right-hand side, but using the x's in one line and then plugging in the 2's on the next organizes my work so that I never am in doubt about why I wrote any particular thing. These numbers at the end, again, just come from the table. F of 2 means go to the 2 row and look in the F column, and the answer is 3. That's where the 3 comes from. How about question 8? Right, question 8 is very similar. The answer was 5/12. This one's a quotient rule. That's because I'm taking the derivative of a function defined to be a quotient. And if you want, as an initial step, it might be helpful for you to write out for yourself that h of x, sorry, not prime, just h of x equals g of x over f of x. And then you take the derivative of both sides. The derivative of this is h prime. The derivative of this is a quotient rule. And then you just plug in your values after you've got the actual expression. And simplifying this, I got 5/12. Great, next question. Okay, so we're now on to part B, which is the section where you can use a calculator, so I'll try and highlight how. For question 9, the first thing you should realize is that we are doing implicit differentiation, which actually means that the calculator isn't going to help you a ton. Let me walk you through the steps. So my first move was to take this equation and differentiate it implicitly. I know that I have to do implicit differentiation because x and y are together in the equation, not isolated. And basically I'm just following the power rule for the first term, the product rule for the middle term, where 3x is one function and y is the second function. And then a chain rule for this expression right here, because the outside function is e to the x, and the inside function is y, which has a derivative of y prime. Don't forget to take the derivative of the second side as well, and the derivative of 6 becomes 0. Now that I have my implicitly differentiated expression, I need to get y prime by itself, basically just solve for the derivative of y. I do that by gathering terms and then by dividing, and I end up with this expression. So the question is asking, what does this equal when x equals 0? I can easily imagine plugging in 0 here, but I also need to know what y is, because I'm going to have to plug in a y as well, and they don't tell me what y is. So to figure out what the y value of the original function is at x equals 0, I plugged in 0 for x in the original equation. That allowed me to solve this equation to figure out what y was going to be. And I ended up with e to the y equals 6, which can be solved using a natural logarithm. In other words, y equals the natural log of 6. Now that I know what y is, I can go back to my derivative. I plug in 0 for x, because that's what they tell me x is. And I plug in ln of 6 for y, because that's what we discovered that y has to equal. The first terms on the top and the bottom go away because of the zeros, and I'm left with 3 times the natural log of 6 over 6. If this is tricky to you, you're going to need to brush up on your logarithms, but the simple thing I can say is, look right here, we just proved that e to the y equals 6, which is why this equals 6. There's also an exponent rule that you could use if you want to think about it. Anyway, negative 3 times ln of 6 over 6 simplifies to negative ln of 6 over 2, and then I plugged it in the calculator and got A. Whew, that was a lot of work. Okay, let's try 10 now. The quickest way to do question 10 would be in your calculator. Use the NDER function, which is also math 8. Be very careful with parentheses when you plug this in, and make sure that you use a -5 as your argument. You don't even really need to graph it. Just do this in the outside window of your calculator. I'm not going to spend too much time on it now because I will go over some more of these in class. Let's go ahead and just talk about question 11. Question 11 is just a simple chain rule. It's not D, it is C. First of all, the chain rule is pretty easy. It's the derivative of the outside, which is f prime. But then what may have tripped you up is that you have to plug in the 2x. So instead of just taking f prime as is, I got rid of the x and set up parentheses, and I plugged 2x in there. When you square 2x, make sure that you square the 2 as well as the x. And then, of course, you multiply times the derivative of the inside, which is just 2. And that 2 ends up on top, which gives you C. Question 12 takes a couple steps, so I'm going to actually work this out with you. First of all, when I read this question, there's a bunch of different terms that I need to kind of interpret. Y-intercept and normal being the primary ones. And they both seem to have to do something with linear equations. The y-intercept is the b value. And normal means a slope that's perpendicular to the tangent. And so we're thinking about a line, which sometimes we use this equation for, with a slope that's perpendicular to a tangent. And then if I can find that equation, I would solve it to get y by itself, and I would look at the b value, and that's going to be my answer. So what can we start with? Well, first of all, we know that the point y1 and x1 comes from this function. In fact, we already know that x1 is -1. So I can find this y1 by plugging -1 into the function. And the most efficient way to do that is just set this up and plug it into your calculator. Okay, now I know x1 and y1, I need to go for the slope. Well, if the slope is perpendicular to the tangent, how about we find the tangent and then take the opposite reciprocal, because that's what perpendicular means. The tangent slope is the derivative of y. And we're going to find it using a chain rule, where the outside function is e to the something, and then we're going to multiply it times the derivative of the inside function. Looks something like this. And again, I'd use my calculator to plug in x equals -1, which gives me a tangent slope of this decimal. So that's the tangent slope. Now we're ready to set up this equation. We just need the perpendicular slope. So to make a perpendicular slope, I'm going to do 1 over this decimal, and I'm going to make it negative. And that becomes the slope of my linear equation. Then I plug in x1 and y1, and then I just solve for y, distribute this, and add 0.2323, which gives me this y-intercept, which makes the answer A. Just answer 13, 14, and 15 so I can show you the answers all at once because we're close on time here. There's 13 and 14.